this thing here, so I'm gonna go ahead and do this thing here. Okay, so the GRE is a test required for admission to mini graduate school. And we're told that the student score follows a normal distribution with a mean of 150. That means that everybody who took the exam or will be taking the exam expect to have about 150 points on average. So suppose a sample of 10 students took the test and found that the sample mean score is 114 with a standard deviation of 11. Test claimed that the mean score is different from 150 at alpha is 0.10 level of significance. Use the critical value method. Okay, now we'll go ahead and look at this preparation step here. We're going to go ahead and compute, well, gather our data or information that we have. And it looks like the mean score for everybody is 150. But one took 10 students and it's 10 and found that the average, so that is the X bar of those 10 students is 144 with a standard deviation of 11, so that is S is 11. Okay, that's what we have. Now, to get to step 1, we need to look at the claim. Well, right here is the claim says that the mean score is different from 150. So, claimed the mean is different, meaning not equal 150. Okay. The alternative claim, odd claim, meaning that if the claim is false, so if the claim is not true, that is mean is not equal 150, then the mean must be 150. Oh, that's easy, huh? That's obvious. Okay. So which of those two will go into H0 and H1? Once again, H1 always have H1 always contains equality, so mu is 150. Okay. And H0 always contain equation, or I'm sorry, equality. H1 is not always contain inequality, so mu is not 150. Okay. Step 2, significant level alpha, we're told is 0.10. It's easy, right? Now, what is our compute the test stat, appropriate test statistics? What are we talking about here? We're talking about the mean. Okay. So we talk about the mean. What about the standard deviation of the population? Do we know that? No, they did not tell us. We're told the mean. We're told the mean, but not the standard deviation. So this is unknown. Sigma is unknown. All right. So look at your formula sheets. Look at the test statistic in your formula sheets. you should see the formula to be T is X bar, I believe it was X bar minus mu. Okay, so double check on your formula sheets. I believe it was X bar minus mu. Sorry, S bar, yeah, S bar minus mu divided by S over the square root of N. Okay. Well, we're gonna plug it in. From the prep step, we know that X bar is 114. Okay. So 144. The mu we're told is 150 right there. Okay, so 150. The S, this is standard deviation for the sample, which is 11. So 11 over the square root of N. We've got 10. All right, now use your calculator. We're going to compute the t-test. So you should calculator, you should get, what should you get? You should get a negative number at least. So t is negative 1.2, actually 1.7248 and more. Okay. I'm just gonna write only up to 4 digits here. All right, the next step then, we want to find the critical value and compare it to the test stat. So now we have the test stat as the t-test. So I want to look at the t critical value. Okay. So the CVT or critical value t. Now to tell us the difference between those two guys, the test stat and also the critical value, okay, because they both use t. So I want to know the difference. So I'm gonna say that actually this book notation, okay, we'll use t sub 0. Okay, so that this t without a sub 0 refers to the test statistics, and the t sub 0 refers to the critical value t. Okay, so we can do this with a z sub 0 for the critical value z score. Okay, so that we can tell, yeah, so that we can tell the difference between the test at t and also the critical value t. Now, to use the critical value t, we will need to know the df, which is degree of freedom, which is n minus 1. Okay. So df will be 10 minus 1, which is 9. So my degree of freedom is 9. I also need to know if I have a left tail or right tail or two-tail test. So here again, go back to the H0, I'm sorry, H1. If H1 is less than, then you have a left tail test. If H1 is bigger than, then you have the right tail test, which is, we saw that in the last example. If we have a not equal like this, then we have a two-tailed test. So we're going to say that we have a two-tail since H1 has the not equal, okay? Now, if I'm going to draw this, I'm going to draw, this is still a normal curve, so I'm going to draw a normal curve. This is a two-tailed test, so we're going to draw both sides of it. Okay. We're going to draw both ends. We're going to draw left tail and right tail. Okay. I'm going to draw with the test stat. I'm sorry, draw with the critical value. So it'll be this will be your t sub 0. And it's also your t sub 0, which is a negative. Okay. So two-tailed tests, we have one positive and one negative. Okay, so in the two-tailed test, you get, if on the two-tailed test, we have a negative z and positive z. If we have the z-score, this case we have t, so we use t, negative t, and negative positive t. Left tail is negative number, right tail is positive number. Now, our alpha is, we're told it is what? 0.1. Okay, 0.1. And it is a two-tailed test. So here we have 0.1. That is a two-tailed test. In other words, this is the area in two-tail. So this is the area in two-tail, okay? So we want to go in and alpha is 0.10, and that is the area and two-tail. Okay, so from the T table, we're going to use df of 11, I'm sorry, 9, and then this guy here, 0.10, the area in two-tails, okay? From the table to give us our critical value T. So look up your T table. Look at area in two-tail of 0.10 and the degree of freedom of 9. So let me put up the table, T table here. So I'm looking at area in two-tail of 0.10. So there we go. Area in two-tail, 0.10 right there. And then I look for the df of 9. So right here, 9. We're going to match this to, we're going to match go straight to the right from the 9, go straight down from the point 10. There we go. Our critical value T this time is 1.833. Now, the fact that we have a two-tailed test, we're going to have a positive and negative 1.833. Okay, so we will go back here. I'm going to put our test score here. So 1.833 on the right and the negative 1.833 on the left. Okay. Again, df of 14. Yeah, df of 14. These two together from a t table to give us our critical value t. Okay. All right. Now, next thing we're going to say, step 5, we're going to reject or not reject the H0. Now, when we do it like this, the critical value method like this, the T is now called a critical value score. And so this area on the left and on the right is called the critical region. Okay. Sometimes called the rejection region. On the left and also on the right. If this is a right-tailed test, then only one side, right? Or left-tailed test, then only one side. But these we have two-tailed test, so left and right is called a critical region. Well, critical means, well, from the critical value, so it makes sense to call it critical region. Rejection regions is because this is the part where we have to reject. Okay. Let me write this in ink here. Okay, this is called the critical region. Critical or rejection region. I like to call the critical. I like to call the rejection regions is because I just put RR here, okay, for rejection region. That is the area on the tails. Okay. Now I like to call it rejection regions because this is the part where I have to reject. This is the area where I have to reject. Okay. So how do I reject it? I'm gonna use a test step to test. Okay. So again, I'm gonna draw. Redoes again. Draw here. So this is a T is again 1.833. This is T is a T sub 0, that is the critical value is negative 1.88. I'm gonna test, okay, using the test stat. So test it out. So right here in the middle, it is right here in the middle it is when t is 0, right? T is 0. I mean, t sub 0 is 0. T sub 0 is 0, okay? So where is my test at? Test statistic t. Our test statistic t is, that is our step number 3, which is negative 1.724. So test statistic t is negative 1.7248. Now we're going to say, where is this test at inside this region? Okay, is it in the R region, left or right, or in between? Well, if I go left, right, I go negative 0, negative 1, negative 2. So the t-test, the test going to show that the test statistic will go right there. We'll go in and say this is a very close here. So that is our t value of negative 1.7. $1.724. Okay. So it is not quite inside the critical region here, or the rejection region. So because of that, we're not going to reject. Okay. So if the test set in the region, then we reject. That's why it's called rejection region. If it is not, then we have to reject. So we're going to say we're going to fail to reject. So we're going to fail to reject 80 because the test stat here, or test statistics, was not in the critical region or rejection region. Okay, so this is how we use our critical value approach. Now, most people now only use the p-value method, but some people still do. Okay. I'm one of them. But most teachers now get away with that's only teach you the only method. The p-value method is more modern. I guess I say more easier to do, I guess. As far as if you use a calculator, the p-value is much easier to get. That's probably why they use the p-value method. All right, anyway, so for this approach, when we draw the graph here, okay, the area on the tails are called the critical region or rejection region. The test, that's why we call it test statistics instead of just critical value. We test, see if the test statistics is in those regions. If the test statistics in those regions, then we're going to say we reject H0. Okay. If it is not, like this case did, then we not reject H0. Okay, now conclusion. So we want based on failed to reject H0 Now we also look at the original claim. So original claim. See if contain equality or not. So here we go back to the claim. The claim says different. Okay. So different means that it's not equal. Right here, right? So this one does not contain equality. Okay. And so use your table 8.3 in the chart. Based on those two conditions, we can say something like this. We can say something like conclusion. There is not sufficient evidence to support the claim that, so we're going to insert the original claim in there. The claim that what? The claim that the mean score is different from 150. So we're going to put the claim right here. All right, so here, together now we can say, okay, so conclusion, we're going to say there is not sufficient evidence to support the claim that the mean verbal score is different from 150. All right, so